So hi, I'm Lindsay Spear. I'm the campaign director for HeatSmart CNY. And we are one of the, I'll pin myself real quick, there we go. So we are one of the 19 community campaigns across New York State that is funded by NYSERDA to do outreach and education around clean heating and cooling technologies like geothermal and cold climate air source heat pump water heaters, and also the importance of insulating and air sealing our homes. I work for Alliance for a Green Economy, and we're partnered with Central New York Regional Planning and Development Board on this project. And we have a great team of volunteers who are on our steering committee, and we've gone through the process of partnering with a number of local installers to basically help get rid of some decision paralysis for people who are participating in our program, so they know that they are working with reputable installers. And so I'd like to introduce Dick Kornbluth, who is a longtime retrofit insulation contractor. He comes to us with about 30 years of experience in home performance, and is just a great resource to our campaign. And he's going to give our presentation tonight. So welcome, Dick.
Thank you. Are you ready?
I'm ready. Am I running the slideshow, or are you running the slideshow?
I'm running the slideshow.
Okay, that's all right. Good. You're ready. Go ahead.
Yeah, I am ready. If I can find it on my, well, let me just 1 second. This is the hardest part, is getting your slideshow on the screen.
There we go.
There we go. Hi, welcome to Heat Pumps 101 for cleaner and greener heating and cooling. My name is Dick Kornbluth. I'm your presenter. First, I want to acknowledge that we in Central New York live on the land of the ancestral land of the Onondaga Nation. And I need to mention also that the Onondaga Nation heats their fire barn with ground source heat pumps. Excuse me, I want to get rid of hiding something here.
We can't see it, so it's fine on our screen.
Okay, thank you. This is the introductory slide to HeatSmart CNY, but Lindsay covered that really well, and I'm just going to skip right past it. So Harvard University, in conjunction with 3 universities in England and Britain, did a study on the health effects of fossil fuel generated air pollution. And what they found was that in 2018, that exposure to fossil fuel pollution contributed to the deaths of almost 8 million people in the world. That's actually 1 in 5 of the world's population. So there are many reasons for getting rid of fossil fuels beyond just the effect on the environment and carbon pollution. So in New York State, the main sources of greenhouse gases in New York State are transportation. But second in place is actually buildings. And it's the building sector where we are focusing our attention to try to reduce the use of fossil fuels in the building sector. So if you look at greenhouse gas generation in New York State, under the current programs that exist in New York State, by 2030, it's estimated that the reduction of greenhouse gas production will be about 16 to 19%. If all of the gasoline vehicles and buildings were shifted to electricity, it's estimated that by 2050, greenhouse gas emissions in the state will be reduced by 50%. And if you increase at the same time, increase generation by renewables such as solar and wind, we can reduce greenhouse gas production in New York State by 75 to 80%. So that's the goal, and that's where we're going with this work. So what is your carbon footprint? Well, there's a handy dandy carbon footprint calculator that's at the EPA website, and we're going to put that in the chat so you can have that link. And using that link, you can get an estimate for what the carbon footprint of your own house is, and see what the potential is for reducing that. So everything begins with the energy audit. It's a discussion of your concerns, including energy and comfort and other issues. And how it works is that you will have a contractor come to your house. And by the way, in New York State, energy audits are free for people who are either paying for the work themselves or who qualify for the Assisted Home Performance Program. So the contractor will come to your house and have a discussion with you about the concerns you have with your house, including such things as rooms, individual rooms or areas of your house that don't cool or heat efficiently, issues with ice dams in your house, issues with moisture problems in your house, allergy issues in your house, and things like that. After doing a test of your house that may include a blower door and an infrared scan, they will inform you, they will get the data and then eventually inform you of potential solutions that may include insulation and air sealing. I'm going to talk a little bit about the blower door. The blower door is a simple fan that's mounted in an open outside door frame of your house. And what the blower door does is it blows air out of the house, which creates a very, very small vacuum in your house. And what that vacuum allows the energy auditor to do is two things. Number one, it can help them actually locate where the air leaks and where the air leakage is coming into your house from. Because when the house is under a vacuum, air from the outside will be drawn into the house through those air leak sites. And the second thing that a blower door does is it gives the tester the ability to actually measure the air leakage rate of your house. This is very important because what people don't realize is that heat not only escapes out of their house through their walls and their windows and their doors, heat escapes out of the house through the air leaks that exist, and we'll talk a little bit more about that. The use of the infrared camera can make the ability to find and locate the air leaks even more powerful, and I'm going to show you an example of that right now. They were brand new many years ago, maybe 5 or 6 years ago. Lemoyne College built a bunch of brand new buildings. They were making so much ice, even though the buildings were brand new and actually conformed to all of the requirements of the New York State Energy Efficiency Construction Code, that the ice dams were so severe during one particular winter that the buildings were considered unsafe to actually enter because of the fear of falling ice. So I was called in to take a look at it. And what I'm showing you right now is a slide. I'm going to get rid of this. What I'm showing you is a slide that shows a section of an interior wall. This is in the summertime. So what happens in the summertime is that when the blower door is on, it will pull air from the hot attic into the cooler living space below. And as you can see that there's this white that you can see here, not super clearly, but this white is actually attic air. And you can see right here is the light. This is the light in the bathroom. This is the same light in the bathroom. And this is actually warm air that's literally leaking down in the corner of the room through gaps in the frame. That's what it looks like. This is what it looks like before the blower door is on. That's what it looks like after the blower door has been turned on. So what this looks like under normal circumstances is a little bit of warm air leaking in when the blower door is turned on and it's pulling that warm air from the attic down into the living space. This is what you actually see. So this is not an outside wall. These are all interior walls. One other quick example. This is another room in the same building, and we're looking at a space directly underneath the attic. Without the blower door running, here's the window, and here's the window. Without the blower door running, the room looks pretty dark. The walls look pretty cool. As soon as the blower door is turned on, you can see warm air literally being pulled down inside the actual stud walls of the interior of the building. Now, this is under the effect of the blower door. What happens in the wintertime is everything that you see here going on here will be reversed, because in the wintertime, warm air from the building will leak through those same gaps and go into the attic. So the second step is to improve your house with insulation and air sealing. So you might be saying to yourself, you know, I'm thinking about getting a heat pump heating system. Why should I insulate and air seal my house? Well, for the first reason, even if you keep your existing heating system, insulation and air sealing will save you money with your existing heating system by reducing heat loss in your house. And it's also been established that heat pumps work much better when the house is insulated and air sealed. Insulation and air sealing lowers the cost of operating your heat pump, since heat pumps are sized to provide the heat your house needs to maintain comfort. The less heat your house needs, the smaller the heating and cooling capacity, and the heat pump can be sized smaller. So you actually save on that score also. The fact is that insulated and air sealed houses are simply more comfortable and less drafty. And attic insulation and air sealing reduces or eliminates ice dams regardless of the heating system. Ice dams are not good things and can damage your house. Now, we've been really fortunate the last couple of years in Syracuse because we haven't had major problems with snowpack and ice dams, but I have encountered years during my work as an insulation contractor where ice dam damage was so severe that insurance companies had to rent entire floors of the Syracuse hotel in order to cover the claims. And finally, insulating and air sealing by reducing the amount of heat that your house needs reduces your carbon footprint. So these are all reasons to insulate and air seal your house, whether you are considering a heat pump heating system or not. So where does the insulation go? Well, it goes in the attic, which can be either spray foam on the roof or blown in insulation on the attic floor. It can be at the basement rim joist. This is the second most important part of the shell to insulate because that is an area at the bottom of the house, and you'll see in a minute why that's important. It's the bottom of the house. It's where your floor joist and your sit on top of your foundation wall, and it's the space between your foundation wall and your first floor of your house. And the third area that should be considered for insulation is sidewalls. Now, a lot of people think that sidewalls can't be insulated, but a really skilled and experienced contractor, first of all, only has to remove, usually only has to remove only one panel of siding in order to get into the entire 8-foot cavity. And a really good skilled insulation contractor can take the panel off, can install the insulation and reinstall the panel with almost no damage whatsoever to the siding. Whether the siding is horizontal, aluminum or vinyl, or wood clapboard or shingles, all of those sidings can be easily removed, and after the insulation is installed, be installed back. It is a fact that that a sidewall insulation job in some cases can actually provide more energy efficiency than an attic insulation job and will drastically reduce drafts and outside noise in your house. So you should consider that. So let's talk about air leakage. If you go out on a calm winter day and you're wearing a wool sweater, that wool sweater will do a pretty good job of keeping you warm. But what happens when the wind blows? Well, when the wind blows, that wool sweater, being porous, is going to allow that wind to blow through the sweater and it's going to cool your body off. So the fact is that under a windy conditions, a wool sweater is not a very good insulating material. So what do you normally do to fix that problem? Well, what you do is you put on a windbreaker. So what the windbreaker does is it stops the wind and essentially it restores the wool insulating value. Once you stop air from going through the wool sweater, it works just fine at insulating your body. Well, it's interesting because your house is very similar in some respects to that wool sweater, except in the case of your house, what's happening is that it's not so much that air is blowing into your house, is that your house is leaky and warm air is leaking out of your house. What you need to understand is that in all buildings in a cold climate, not just houses, but all buildings in a cold climate, as long as the inside temperature of the house is greater than the outside temperature, warm air will rise through the house and exert an actual measurable positive pressure at the top of the house, kind of like a hot air balloon. At the bottom of the house, the reverse is happening. So what's happening is that in your house, there are gaps and holes that you cannot see from inside the house that is allowing that warm air to escape into the attic and cause heat loss and cause ice dams and melting snow, etc. And the reason that you can't see those gaps and holes is that they're inside the framing of your house. Now, give you a simple example. There is a pipe that starts in the ground, runs all the way through your house and exits through the roof. It's part of your plumbing system and it's called the plumbing stack vent. So here's the plumbing stack vent. You can't see that stack vent because it's completely inside a wall cavity and it's inside the framing of your house. That plumbing stack, the gap between that pipe and the framing around that pipe is like a super highway for warm air to escape. If you look at other areas of potential sources of leakage, you can include things like attic hatches and recessed lights. It's even the case that the actual joint at the top of your interior walls where the sheetrock meets the top plate, there's a little gap that can be as small as a 1/16 to 1/8 of an inch, and that gap will actually leak warm air. You actually saw that in the actual slide I showed you of the buildings at Lemoyne College, where the interior walls, the actual interior walls themselves were leaking warm air into the attic, because when the blower door was turned on, it was pulling that air, warm air from the attic in the summertime into those slots. So at the same time that you're leaking air out the top of your house, because nature doesn't like a vacuum, it's going to replace that air by bringing in cold air at the bottom of the house. So air leaks into the house at the top and leaks into the house at the bottom and out of the house at the top. And both of those leakages are actually detrimental to the energy efficiency of your house. So this is what the contractors do as part of their job when they insulate your house, is that they air seal these. So why doesn't the insulation in your house work to stop that leakage? Well, the fact is that insulation like blown insulation or fiberglass bats, they're actually like that wool sweater. They're really porous. And because they're porous, they allow the air to go through them. So what you do in an attic, which is comparable to putting on the windbreaker, is you air seal the attic plane, which is below the insulation in the attic. And what that does is it's not only stops the air leakage, it actually restores the insulating value of that fiberglass or cellulose. So how do we do the air sealing? Well, we basically use the standard tools that you would do to seal cracks and holes, which is spray foam or caulk or weather stripping in the case of attic hatches or doors to the attics, etc. So I'm going to talk a little bit about heat pumps. There are three basic heat pump technologies that can meet your home and energy needs. One is a ground source, or called geothermal or ground source heat pumps. The second is air source heat pumps. And the third, which is actually a variation of the second, are heat pump water heaters. Now, what they all have in common is that none of these technologies actually depend on the combustion of fossil fuels. And the second thing is, if they don't create heat, what do? They are actually in the business of transferring heat. In the case of ground source or geothermal heat pumps, they transfer heat from the ground into your house. In the case of air source heat pumps and heat pump water heaters, they transfer heat from the air, outside air, in the case of air source heat pumps, or in the case of heat pump water heaters, the surrounding air. They transfer it either to the air in your house or into water in the case of the water heater. So they are really devices that are designed not to create heat by burning fossil fuels, but to transfer heat by using electricity to do that. And because of their design and because of the technology that's incorporated within them, their efficiency at doing this transformation process is much, much greater, that not only can be done by fossil fuels, but actually that can be done by standard air conditioning technology, for example. So what are the benefits of heat pumps? Well, there are many benefits of heat pumps. One is that heat pumps reduce energy costs. For a start, if you currently heat your house with oil, propane, or baseboard electric heat, heat pumps will significantly lower your heating costs by several times. Second, they provide more even temperatures and the ability to heat different zones in the house in the case of some of this technology. And they can cool much more efficiently than current technology, air conditioning technology can do. Because they don't require combustion, there is absolutely no risk of accidentally generating carbon monoxide inside the house, which can be deadly under certain circumstances. Since they do all of this using electricity, they create the prospect that if you add solar generation of electricity, that will work with your heat pump technology to even reduce your costs further and reduce your carbon footprint even further. And finally, heat pump technology significantly reduces greenhouse gas emissions and lowers your home carbon footprint. So what we're going to look at next are going to be two short videos from NYSERDA that talk about geothermal, ground source, and air source heat pumps.
Heating and cooling your home account for more than half the energy in a typical home, making it the largest expense and largest greenhouse gas emitter. But did you know that even though the weather around us changes throughout the year, the ground underneath is able to stay at a constant temperature all year round? That's because the ground soaks up 44% of the sun's rays and stores it like a battery. What if we were able to put this ground battery to good use? That's exactly what a ground source heating and cooling system does. How does it work? An underground pipe system is installed to access the ground's constant temperatures. In the summertime, the earth is cooler than your home, so excess heat from the home is transferred to the ground. As the warmer water comes into contact with the ground, it naturally cools off, which then returns to your home to extract more heat from the house. In the wintertime, the earth is warmer than the outside air, so heat from the ground can be transferred to your home to heat it up. The closed-loop system is providing a continuous supply of warmer temperature to your home. By taking advantage of the sun's energy that's stored underground, ground source heating and cooling systems bring homeowners many benefits. They're quieter and more efficient to operate. In fact, for every unit of energy that these systems use, they can provide 3 to 4.5 times that in heating or cooling energy. They're emissions-free in your home, reducing your carbon footprint. They also require less maintenance and last longer because the system is protected from the weather. Lastly, they cost much less to operate. Ground source heat pumps can be installed in existing homes and buildings and new construction. New York State offers a rebate for the installation of a new ground source heat pump system in your home or building. There are several different types of ground source heat pump systems that you can choose from that best fit your needs. You can get started by contacting a NYSERDA qualified designer and installer. They'll help you get the right type of system and apply for the rebate. There are many ways to heat and cool your home. Air source heat pumps move heat between the outside and inside of your home to keep your home a comfortable temperature all year round. Recent technology advancements in air source heat pumps now make them a strong alternative for space heating in colder regions like New York State. Ducted air source heat pumps are central systems that provide heating and cooling through your existing ductwork. Ductless heat pumps, also known as mini splits, are an example of an air source heat pump system that consists of 2 units, a slim outdoor condenser and an indoor air handler. Ducted and ductless air source heat pumps have several benefits over conventional HVAC systems. They're quiet to operate and highly efficient because they move heat rather than convert it. There's no combustion of fossil fuels, which leads to safer operations and cleaner air, and a lower carbon footprint. It also means that you can save money on your heating bill if your home is currently heated with fuel oil or propane. On top of that, what's unique about mini splits is that the indoor air handling unit is in the same room that is being heated or cooled. This indoor unit is connected to the outdoor condenser through a small opening in the wall or ceiling behind it. This means that mini splits don't require ductwork to carry warm or cold air throughout the home. No ductwork means that mini splits are very space-saving and flexible in where they can be placed, making them perfect for renovations and home additions. Are you interested in learning more about a ducted or ductless air source heat pump for your home? Here are some tips to keep in mind. Work with an HVAC contractor in your area to size the unit appropriately, and be sure to pick an air source heat pump system that is designed for a cold climate. For more information, visit the NYSERDA website.
So talk a little bit about air source heat pumps. First of all, there are basically two types of air source heat pumps. One is not called a regular or non-cold climate air source heat pump, which is suitable for climates down to about 30 or 35 degrees. But there's also a cold climate air source heat pump, which will deliver heat at outside temperatures below 0 degrees and will work very well in central New York. That is the only kind of heat pump that should be installed in the area we live in. And for the rest of this presentation, I'm going to refer to air source heat pumps. And when I do, I will be specifically referring to cold climate air source heat pumps. So what kind of configurations do they come in? Well, the most common one is what you saw in that video, which is a ductless mini split with a single zone. It's the most common, and it conditions a single room or common area. But there's also what's called a multi-zone ductless mini split, in which you have a single condenser on the outside of the building, but you can have more than one air handler on the inside of the building. And in fact, you can have up to 4 separate air handlers inside the building. And what this means is that you can condition multiple areas in the house from a single outside condenser. And it gives you the ability to individually control the flow from each of those interior air handling units. So you can have different different performance based on what your needs are. And there's also what's called an integrated or ducted multi-zone system, which is a whole house system, which uses actually the distribution system of a central furnace. So it would be integrated into the central furnace distribution system so that you can actually use the ductwork of the house to treat the whole house. So this is another example or diagram of the interior unit, which is called the air handler. And these are examples of outside condensers. And I want to call your attention very specifically to one of these, which is that one. And if you'll notice, that outside condenser is sitting literally adjacent to a deck. Now, if you have central air conditioning, you know how loud the compressor of a central air conditioner can be. And one of the really valuable features of this technology is that these outside condensers are incredibly, incredibly quiet. And so in this case, it was totally possible for these folks to have this condenser sitting right next to their deck and be able to use their deck and enjoy the quality of life on the deck without having to deal with the noise that would be generated by a traditional air conditioning compressor. So the indoor units, they can be mounted in several different ways. They could be mounted on the wall. They could be mounted on the floor. And they even can, in certain circumstances, and given the right configuration in the house, they can even be mounted in the ceiling. So you can have air source heat pump with wall air handlers or floor air handlers, and even ceiling units. So the third option was an integrated ducted air source heat pump with an outside condenser that is connected directly into the furnace and is actually using the duct system of the house to distribute heat. It's important to note here that when that happens, if you go that route using the furnace distribution system, because, and I might mention this later also, because the temperature produced by air source heat pump is not as great as the temperature produced by a fossil fuel combustion. It's sometimes necessary to actually modify the duct system to make sure that the comfort is actually maintained in the house. So this is a case study. This is a house in Cayuga County. And this house had 2 outdoor units installed. Those 2 outdoor units, which were 2 condensers, serviced 4 indoor air handlers, which meant that each of those outdoor units actually was connected to 2 indoor air handlers to create the necessary flow of comfort in the house. In this case, the entire oil heating system was replaced. The cost of the system, initial cost was $18,838. There was a NYSERDA rebate. And in fact, there was even a better utility rebate. So the final cost of the system was $13,478. And the house also did extensive insulation and air sealing. Air source heat pumps are not just for residential buildings. They can be installed in commercial buildings. For example, the Preble Town Hall is heated and cooled with air source heat pumps, as is the Hamilton Fire Department, and a large 19th century building in Skaneateles called the Sinclair is also heated and cooled with air source heat pump technology. So this is an interesting case study. In this house, the homeowners actually called for an energy audit because they were interested in getting their house insulated. And in the course of the energy audit, it was discovered that their furnace was actually producing carbon monoxide. So they ended up with a hybrid system or dual fuel system, which included an air source heat pump to heat part of the house and a brand new high efficiency gas furnace to actually replace the exceedingly dangerous existing furnace that they already had. And in addition to that, they had insulation done in their house, extensive insulation work done in their house. So one of the possible technologies that can be done is what's called a dual fuel or hybrid system. Although I will tell you that that NYSERDA over the next year or 2 is going to be discouraging the installation of fossil fuel heated equipment. So I don't know for how long technology like this will be available. So I'm going to talk a little bit about ground source heat pumps. The ground source heat pump consists of 2 parts. The first part is the loop, and the loop can either be a vertical ground loop, which is installed in a well that can be drilled from 250 to 500 feet deep, or in the horizontal loop, which can be installed in trenches that are dug into the property. What goes into that vertical well or into that horizontal trench is a PVC or PVC pipes, or they're pipes that contain a mixture of water and propylene glycol, so it's completely non-toxic. And what those ground loops do is they are the place where the transfer takes place between the ground and the water glycol mixture, which is then connected into the equipment that's inside the house, which looks like the diagram on the left. And you can see this is the vertical loop, this is the horizontal loop, and this is the point where the 2 ends of the loop are actually connected into the equipment. Now, what's to be noted here is that inside the house, the equipment inside the house is not massive. It really looks very similar to what a furnace might look like, even though it's much more sophisticated than a typical combustion, fossil fuel combustion furnace. Just to give you a quick idea of the principles of all this, you have a ground loop in which heat is being transferred from the ground into the loop. That heat is then transferred inside that equipment you just saw to a refrigerant system, which then transfers the heat into whatever the distribution system in the house is. So it could be ductwork, or it could be hot water pipes. So it could be it could be into ductwork for distribution through heating ducts, or it could be into hot water pipes for radiant heating. And what you see in that last drawing is that piece of equipment is doing all of that work that you just saw, which is the two-part transfer from the ground to the equipment and from the equipment into the distribution system. So almost any house can be nearly net zero and can have and achieve that through the installation of heat pump technology. So here's a series of homes. You'll notice that they are different styles and different ages and different configurations, but there's really no limit in terms of what can be done in houses in terms of making them almost net zero, nearly net zero. What does net zero means? Net zero means that the house can be heated and comfort maintained without the input of any outside fossil fuel source. And so it's possible by combining solar with heat pumps to achieve that. I'm going to focus really for a little bit on one of these houses. This is a mid-19th century farmhouse in Onondaga County. The house was traditionally heated with propane and I think oil or propane and wood. And the owner of the house decided to go to a ground source heat pump and also to go with a solar system. So we're going to dig into that. At the end of the work, her energy bills were literally $20 a month. I actually know where this house is, and it sits basically sits on the side of a hill across a valley where the wind literally howls in the wintertime. I have been to that house and I have been there in the winter, and I have actually encountered what I thought was snowfall that turned out to be ground-to-ground snow driven by the wind that was actually piling up big piles of snow around this house. So this house is not just sitting on flat ground, it's sitting in a place that has extreme weather in Onondaga County. So let's look at this project. Formerly wood and propane, and now solar and ground source heat pump. She had originally the cost of her system was $36,571 for a 4-ton system. She had with a rebate from NYSERDA. She had the 30% federal tax credit. She also had a rebate from National Grid. And so her final price on that project was $20,757, which literally was a 43% cost savings from the original estimated cost of the work. In addition to that, she had a brand new electric service done. She had some insulation and air sealing, and she had ductwork modifications to ensure that comfort was delivered to all parts of her house. And she had a $20,000 solar system installed to provide additional, additional electricity to the house. And all of that resulted in utility costs in an old farmhouse on the side of a hill in Onondaga County of $20 a month. So this is a geothermal home in Manlius. In this case, there were 2 vertical geothermal wells drilled. Each well was 250 feet deep. And afterwards, the land was leveled and reseeded. Each of those wells serviced, or each of these wells supported a ground source heat pump system. There was one that was for space heating, and there was one for water heating. So the ground source heat pump, the 2 ground source heat pump systems had an initial cost of $68,800 plus, and a final cost of $39,000. And the solar system had an initial cost of about $40,500, and that was cut roughly in half. So the initial cost of the ground source heat pump, with all the tax credits and all the incentives from NYSERDA, it was reduced by 44%, and the solar system was reduced cost by over 52%. We're going to look a little deeper at the performance of this house. After the work was done, for this 2,000 square foot house, the cost of heating and cooling the house was literally only $540 a year. And we're going to get a little bit closer look at that. So before, they were heating with gas, and they were burning 893 therms. Therms is a unit of heat for gas, and it's equivalent to 100,000 BTUs. And the cost of that was almost $1,000. And in their house, they were generating over 3 tons of carbon dioxide a year. Afterwards, just on the heating side with geothermal heat, they were actually using 3,400 kilowatt hours. Now, kilowatt hours is a unit of energy associated with electricity, but to understand what that really means, you need to convert it to units so that you can compare what's done afterwards with what was done before. And by doing the calculation, that was equivalent to 116 therms. And what that represented was an 87% reduction in the amount of energy that was needed to heat their house. And that was completely reflected to the same extent in the amount of carbon dioxide that was created, which went from 3.2 tons of carbon dioxide to 0.4 tons of carbon dioxide. So if you look at everything, at the whole house, what you see is that for the whole house, which is not just heating, and it was also cooling, and it was also all of the base load, what's called the base load in the house, which is everything in the house that uses electricity. What was done was that there was an 85% reduction in CO2 emissions in total with the solar system in the house. So ground source heat pumps are not just for houses. They are also for commercial buildings. So the Auburn Memorial City Hall, which is a neo-colonial building built in the 1930s. The Scheiman Science Center in Oswego, which is a brand new building. The Pike Block in downtown Syracuse, the Marcellus Library, the food bank, all of these buildings are actually heated right now with ground source heat pump technology. So what are we looking at when we look at fossil fuels and we look at fuel costs? The problem right now is I don't know when the data was actually collected for this slide, because right now we're in a period when fossil fuel costs are changing rapidly, probably day by day. But the thing that is useful to notice is that the most expensive heat that you can heat a house with is electric resistance heat, followed by propane, and followed by oil and natural gas. And if you look below, the equivalent in terms of the generation of energy of air source heat pump, the cost of air source heat pump is basically 2.5 times lower than electric resistance, and ground source heat pumps are even more efficient. They're like four times lower. So air source heat pumps and ground source heat pumps are extremely efficient ways to heat a house, and they also provide, in addition to that, they provide the opportunity for cooling in a house, which you would have had to do with electric heat. You know, if you had your house was heated with propane, oil, or gas, and you didn't have central air conditioning, you would have to add that with a separate central air conditioning unit. Now it's built in, at least to the ground source system, if you have ductwork. And it's possible with air source to do it on a room by room or area by area basis. So the savings in terms of cost of heating and cooling is really dramatic. So very quick comparison of the technologies. In terms of energy efficiency, the numbers you see, which is 250% and 400%, are all based on comparing the cost of the energy compared to heating with electric resistance heat, which is sort of the standard of 1. So air source heat pumps are 250% more efficient than resistance electric heat, and ground source heat pumps are 400 or 4 times more efficient than resistance electric heat. Can you use the pre-existing heat distribution system? Well, if you have mini splits, each mini split is providing a separate zone and does not need to be ducted. But you can have ducted versions of that, and you can have multi-head mini split systems so that you can treat more than one area in the house. If you're talking about ground source heat pumps, there needs to be a distribution system. Unlike air source, where the heat is actually delivered at the location where the system is installed, for a ground source heat pump, you either need hydronic or ducted air in order to distribute the heating and cooling. Obviously, they both provide, they both have the potential to provide air conditioning. In the case of ground source, you need ducts for air conditioning, so it doesn't really work if you're only using it with a hydronic water system. In case of zone control, in other words, can you treat different parts of the house separately and have different temperatures in different parts of the house? In the case of air source heat pumps, with multi-head systems, you can actually do that. With ground source heat pumps, it's available, but there's an extra cost for that technology. So what's the average lifespan for an air source heat pump? It's about 15 years. For ground source heat pumps, you really have two different parts to it. The ground loops will be there essentially forever, but at least 50 years. And I can think of nothing that will disturb them short of an earthquake. So once they are installed in the ground, they are essentially there forever. The mechanical equipment, on the other hand, which is actually sitting inside the building, has a standard life of most mechanical equipment like furnaces and et cetera of about 25 years. So the issue of weather sensitivity, there's really none for ground source. Everything on the outside is buried in the ground. In fact, the concept of ground source is you have to get below the frost line to actually extract the heat. In the case of air source heat pump, it's really about how it's installed. So you have a piece of equipment that's sitting outside the house, and we can have potentially 3 to 4 feet of snow on the ground. As long as that condenser is mounted high enough on the side of the house, then there should be no problem with weather. Air source heat pumps basically have almost no disturbance of the ground. And as you saw with ground source heat pumps, there really is a lot of outside disturbance. It's either, it's either a well drilled with a trench to bring the two lines into the basement for the equipment, or it's a large field where you can dig a trench. So that, but it's a one-time event, and once that is done, it's not a problem afterwards. And both of these technologies have extensive incentives available, both from NYSERDA and the utilities, and also from HeatSmart CNY. So finally, the last of the 3 types of heat pumps is a heat pump water heater. And essentially, it's an air source heat pump sitting on top of a water tank. And what it does is it takes heat in, it takes heat out of the surrounding air of where it's located, and it transfers that heat using air source heat pump technology into a tank of water to heat the water up. It's incredibly efficient compared to, for example, an electric resistance heat water heater. But it has some issues that have to be addressed when you're thinking of installing it. First of all, because it's actually taking heat out of the surrounding air, it will to some extent cool the air in the location of where it's located. So if it's in a space that's kind of living space of any kind, it could cool that space off a little bit. Second of all, it needs a lot of room. You can't put it in a closet the way you can put an electric water heater in a closet, for example. And third is that there is a fan inside that device, and that fan is running when that device is heating the water. So it's not completely quiet. It's not really entirely silent. So you have to be aware of those issues when you have one installed. But just in terms of the efficiency with which it can heat water, it's really, really efficient. There's also, if you have a high demand, an extremely high demand, let's say that you have people visiting you, instead of having 3 or 4 people in the house, you have 5 or 6 people in the house. It's possible that the demand for hot water can overcome the air source heat pump's ability to deliver in a heat pump water heater. In that case, there is a backup electric heating elements that will actually be triggered. Now, that's obviously a more expensive way to heat water, but what it does is it ensures that you will not run out of hot water under those circumstances. So let's talk about the financing part. NYSERDA right now runs 2 low moderate income programs. There's what's called the Empower program, and the Empower program is based on incomes that are less than 60% of the area median income for the area. And you'll see what that income, those income numbers are. And the second low moderate income program is called Assisted Home Performance, which is for people whose income lies in between 60% and 80% of the area median income. So for a family of 4, for example, If your income is below 60,226, you will qualify for Empower. And if it's above that, but below 80,301, you qualify for Assisted Home Performance. If you happen to have income that is higher than what you see here, there is also a program called Comfort Home, and we'll talk a little bit about what those incentives are. So NYSERDA right now is running 3 programs that provide incentives for doing this work, which is in the form of rebates and access to low interest financing. There are 2 at the low and moderate incomes level, and there's 1 at what's called the market rate, which is called Comfort Home. So quick comparison. If you are at that less than 60% median income, you can be eligible for a $10,000 grant, which would cover insulation and energy efficiency. And I believe now, which is exceedingly recent, and the installers can correct me for this, they're now going to be covering heat pumps, which was not true before. If you are qualified for the Assisted Home Performance, with less than 80%, you have a matching grant of up to 50% of, I believe, $10,000. So there's a $5,000 grant, and it covers insulation, air sealing, and heat pumps. And for everyone else, there is a grant or a rebate, whatever you want to call it, that varies depending on the work that you're having done. Both Assisted Home Performance and the Comfort Home programs are both eligible for low interest financing through NYSERDA. So the Comfort Home programs, they have an interesting structure to their incentives. It's based on the amount of work that gets done. So if you have air and duct sealing and duct insulation, you're eligible for $500. If you add insulating the attic and the rim joist, that adds another $500. If you add insulate attic and rim joist and insulate the walls and insulate a floor, for example, which might be a cantilever or a garage ceiling, that brings the cost, that brings the incentive up to $2,500. And if you do all of that stuff and you also install some Energy Star windows, and I don't know how many you need, but if you install some Energy Star windows, you will be eligible for an incentive of $4,000. So it's really a matter of working out with your installer which one of these packages will, first of all, solve your problem the best and work best for you. So there are incentives specific for heat pumps. There are utility rebates from National Grid, New York State Electric and Gas, and RG&E, and it's based on the size of the equipment. So BTUH, or BTU per hour, is a measure of the capacity of the equipment to heat and cool. And so the first incentive is $1,000. This is for cold climate air source heat pumps per 10,000 BTUH of the equipment. So if you have what's called a 2-ton unit, each ton is considered 12,000 BTU. That would be 24,000 BTU. You would be eligible for 2,000, and I think they do fractions, so it would be 2,200, for example. In the case of ground source heat pump, it works the same way, except that the amount per 10,000 BTU is greater. And in the case of heat pump water heaters, it's a fixed amount of $700. There is currently a federal tax credit, and that credit is $300 for cold climate air source heat pump. And until 2023 for ground source heat pumps is 26% of the entire price of the project. And for heat pump water heaters, it's $300. HeatSmart itself, the HeatSmart CNY, has an affordability grant, which you can see varies from $5,000 per home to $7,500 for ground source and $750 for heat pump water heaters. And if you have a large commercial building, which is defined as a building that takes more than 300,000 BTU per hour to heat, by the way, the average house is somewhere usually between 30 and 100,000 BTU for a really big house. So we're talking about a really large building. They have an incentive that is actually based on calculated savings. So what do people install? What is the history of HeatSmart CNY's experience. So let's look first at insulation and air sealing. So what you'll notice is that some people really just did the insulation and air sealing. So there were roughly 45 projects done, and about 20 of them were people who only did insulation and air sealing, but the rest, which is about 25, did insulation and air sealing, which was part of a larger project that involved heat pump technology. So moving over to air source heat pumps, the overwhelming type of air source heat pump that was installed was a ductless mini split, which is this green area right here. There were a few ducted systems. There was one or two ducted systems, and there was a dual fuel system, et cetera. And then there was one that might have used the standard air source heat pump, or we're not sure. But the vast majority of air source heat pumps were ductless, single ductless mini splits with one outside condenser and a single inside air handler. If you go and look at the ground source heat pump systems, you'll notice that the purple represents the horizontal loops and the blue represents the vertical loops, and they were almost 50% more in terms of numbers than the horizontal loops. They were more commonly installed. First of all, horizontal loops require large plots of land. Vertical loops can be done almost anywhere, given that a drilling rig can get there. There is a house in Syracuse that's in a neighborhood of houses that were probably the average age of the house is 70 to 80 or 90 years old. The houses are all literally 10 feet apart. They just literally 10 feet apart. And we have we know someone who had a vertical loop, a vertical well put in and a ground source heat pump put in, where they actually drilled the vertical well right through the middle of his driveway and through his front yard, which, by the way, was a plot of land about 10 feet by 10 feet in front of his porch. The hole that they drilled in the driveway was complete once the well was drilled and all this, the loops were installed. That hole was completely filled in, so there's no trace of it actually ever having been there. So the possibility for ground source heat pumps is actually pretty substantial as long as a drilling rig can get to the place. Open loops are very uncommon. What that means is that you have the loop going from the equipment inside into a body of water, like a pond, where it sucks the water in and then returns the water to the pond, but they're not very common. And finally, we have heat pump water heaters, and we've done about 15 of those over the last 2 years. So what has been accomplished by all this work? Well, during the first 2 years of HeatSmart CNY, we have sequestered about 360 tons annually of reduced carbon dioxide, which over 20 years would be about 7,642 tons. We have taken the equivalent of 71 cars off the road every year. We have reduced or eliminated emissions from burning 756 barrels of oil a year. And we have sequestered by the equivalent of planting 114,600 new trees over 10 years. So we've done a lot of good, but we have a lot more to go, as everybody can see. So where do you start? Well, you sign up for a home assessment. You have the experts come to your house, and they will talk to you about, number one, about what are your issues in the house? What is it that's not working for you in your house? They will look at your house. They will do a blower door. They may do an infrared inspection to find where the insulation may be missing or where there might be air leaks. They'll tell you more about the technologies available. They'll give you the options for financing and incentives, and then they'll produce a proposal for the work and include in that proposal what the potential and opportunities are for incentives to reduce the cost. And then you sign a contract and install. What else? Spread the word. Help us. Once you get your house done and your life is transformed, be willing to have an open house, assuming that we will be back in the business of actually being in people's houses again. or we can do it virtually where you let us tour your house and see the work that was done. You can volunteer to help us plan future events and work with us to get the word out, and feel at any time free to talk to us. So who are the installers? This is what's important for you to know. Every one of these installers is a BPI accredited contractor. And BPI stands for the Building Performance Institute. And Building Performance Institute creates the standards for the industry we're in, and also creates the certifications for the technicians who work in the industry. The second thing you need to know is that NYSERDA requires that all the contractors in their program meet extremely high standards in terms of workmanship, performance, and professional business practices. So all of these contractors have been vetted. They've been vetted by BPI so they can get their accreditation, which includes a written contract that they will, that they will commit themselves to do things by the standards and by the rules that BPI promotes. They are vetted by NYSERDA, who makes sure that the contractors have also, reached that high level of competency and professionalism. So you can trust that when you work with a contractor through the, through HeatSmart CNY, that you're dealing with the best of the best. Some of the contractors are specialists like ACES and NP, who really do heat pumps, either geothermal or heat pump water heaters or air source heat pumps in the case of NP. And some of them do everything, like Halco or Snug, who do basically all the work that can be done, and simply installs, can do both the air source heat pump and the home performance work, the installation work. So these are the people we work with. Some of them are here tonight, and we encourage you to ask them questions and interact with them. If you happen that you're on this call and you don't live in the HeatSmart CNY territory, which is the 5-county area of Cayuga, Cortland, Onondaga, Madison, and Oswego, you will definitely live in some HeatSmart campaign territory. Let us know where you live, and we can help you find the right territory, the right HeatSmart campaign for you to work in. And that's it. And I thank you very much.